Welcome back to my YouTube channel. This is Kirtana, currently pursuing my second year BE in Electronics and Communication at Sri Venkateshwara College of Engineering, Bangalore. Today I am back here with the course Electronic Principles and Circuits. And today's topic is feedback in voltage amplifier. So now let's look into the introduction to voltage amplifiers. Voltage amplifiers are essential components in electronic circuits. They increase the amplitude of voltage signals, making them suitable for processing. Understanding feedback mechanisms is crucial for optimizing amplifier performance. So, what is feedback? Feedback is the process of returning a portion of the output signal to the input. Now, let's look into the types of feedback. So, basically, feedback is classified into two types, that is, positive feedback and negative feedback. Negative feedback is commonly used in voltage amplifiers to improve stability. Positive feedback enhances or amplifies an effect by it having an influence on the process which gave rise to it. Before moving on to the mechanism types, that is, the feedback types, let us look into the importance of feedback in amplifiers. Feedback influences the gain, bandwidth, and distortion of the amplifier. It enhances linearity and reduces the sensitivity to component variations. Proper feedback design can lead to improved overall amplifier performance. Now let's look into the negative feedback mechanism. In negative feedback, the feedback signal opposes the input signal. This results in a reduction of overall gain but enhances linearity. It also helps in minimizing distortion and improving frequency response. Here I have attached a flow diagram which helps for better understanding of negative feedback mechanism. Positive feedback mechanism. Positive feedback reinforces the input signal, increasing the gain. It can lead to oscillations if not carefully controlled. This type of feedback is often used in specific applications like oscillators. Feedback topologies. The most common feedback topologies include voltage series and current shunt. Each topology has unique characteristics affecting the circuit behavior. Understanding the topology is vital for designing effective feedback networks. Here in the attached circuit diagrams, it includes voltage series and current shunt feedback topologies. Effects of feedback on gain. As we have seen, the feedback helps in the gain, bandwidth and distortion. Now let's look into the effects of feedback on gain. Negative feedback reduces the overall gain of the amplifier. However, it can improve gain stability across varying frequencies. The characteristic makes feedback essential in precise signal amplification. Distortion reduction. Feedback significantly reduces harmonic distortion in amplifiers. By correcting the output errors, it enhances signal purity. This is crucial in applications like audio amplification where sound quality matters. Here in the attached graph, we can observe the distortion where it reduces the harmonic distortion and enhances the purity of the signal. Stability concerns. While feedback can improve performance, it may introduce stability issues. Designers must analyze phase margins to ensure stable operation. Compensation techniques can be employed to mitigate these risks. Applications of feedback in voltage amplifiers. Feedback is widely used in audio amplifiers to enhance sound quality. In communication systems, it ensures signal integrity and reliability. Feedback mechanisms are also critical in operational amplifiers for various applications. Last, let's look into the future trends in feedback technology. Advances in feedback technology are leading to more efficient amplifiers. Integrated circuits are increasingly utilizing sophisticated feedback mechanism. Future developments will focus on enhancing performance while minimizing size and its cost. Thank you for watching. Please do like, share and subscribe my channel.